So the last couple of days I've been thinking about this question again. The 1957 complex number question for the Leaving Cert higher level. And I couldn't accept that the way I did it was the way you were supposed to do it. It was just ridiculous. It took so long and it was so much work. And I was thinking, man, this isn't it. This isn't it. There must be some technique, some rule that I haven't seen before that's a better way of doing it. And the answer is yes. After a little bit of Googling, I did find an algebra rule that I've not seen before that turned out to be very helpful here. So I was on the right track here in this question. By calling this x and y, and this is x and y, I had the idea that what they're asking you to factorize is x cubed plus y cubed, which is x plus y times x squared minus xy plus y squared. That's true. That's a very common algebra rule. But what I discovered in my little bit of research last night is that there's another algebra rule here that says x cubed plus y cubed can be factorized as follows. X plus y times x plus omega y times x plus omega squared y. Now that's more interesting. So we already know what the x plus y is, because I did that in the previous video and they asked us to prove that it's equal to 2a minus b minus c. The x plus omega y, that would be a plus omega b plus omega squared c plus omega a plus omega cubed b plus omega squared c, and then x plus omega squared y, so that would be a plus omega b plus omega squared c plus omega squared a omega squared a omega 4 b plus omega cubed c. Now I just want to make sure I got these right before proceeding. Omega cubed, omega squared, omega 4, omega cubed. Yeah. Now let's start simplifying. Omega cubed is 1. So I can actually... what's gone wrong? Okay. Omega cubed is 1, so that's gone. And that's gone. And omega 4 is omega cubed times omega. So actually the 4 is gone. Okay, so also 1 plus omega squared is 0. So we might have to use the fact that omega squared is minus 1 minus omega. So maybe we'll see what we get if we clean this up. So how many non-omegas are there? A plus B. Okay, great. A plus B. How many omegas are there? Omega A plus B. And then how many omega squares are there? C plus C. And then here, how many non-omegas? A plus C. How many omegas? B plus B, 2B. And how many omega squareds? A plus C. A plus C. All right. I think I'll use my omega squared equals minus 1 minus omega. 2a minus b minus c. So that's minus 1 minus omega. So this would become a plus b minus 2c plus omega a plus b minus 2c. And then this one here would be a plus c minus a minus c. That's interesting. So when you multiply, replace the omega squared with minus 1 minus omega and multiply it out, those guys will cancel with those guys. So you're just left with minus omega. So, okay, so that would be omega 2b minus a minus c. 2a minus b minus c, and then I can factor out a plus b minus 2c, and I'm left with 1 plus omega times omega times 2b minus a minus c. So if I multiply omega in, I'll get omega plus omega squared. And omega plus omega squared will be minus 1. And then I can multiply the minus 1 into that guy. Oh, I wrote 2a there. Sorry, that's 2b. I can multiply the minus 1 in. So I'm left with 2a minus b minus c times a plus b minus 2c times a minus 2b plus c. Oh my, that was so much better. And I'm actually going to check the answer I got last time. 2a minus b minus c, 2a minus b minus c, a minus 2b plus c, yep, and a plus b minus 2c. I don't believe it. I don't believe it. That's fantastic. That's absolutely fantastic. So instead of taking 20 minutes, it took 7, as it should be. Okay, well, I've definitely learned something new, and I hope you have too. That was a very interesting question. I don't know how I feel about it. Do I like it? Do I hate it? Mixed emotions.